Alright, this is the last section of Unit 2 that will get covered before the test and before the final. It involves putting equations in vertex form. Vertex form is y equals a times x minus h squared plus k. Okay? This thing has a vertex of hk and an axis of symmetry of x equals h. So it's very useful to have equations in vertex form because we can just tell where their vertex is. We can also tell, remember, by looking at a whether it opens up or down or whether it's narrow or wide as compared to the parent function. So let's look at this problem 193. It's from the class work which I assigned for homework. And so we want to complete the square on it. Or at least rather put it in vertex form. And to put it in vertex form, we want to focus on the x squared term and the x term, the linear term. That's the part we want to complete the square on. Okay. So if you remember when we did this to solve equations, we used to take the c value to the other side. Well, we can't do it in this problem because the other side has a y on it instead of a 0. And we want to have y all by itself. So in order to remedy this when we complete the squares, we just group the quadratic term and the linear term together. And I like to, in a problem like this, leave a space. In fact, I usually put a plus sign and put a space. Then I put my minus 5 on the outside. And then I also put a plus sign and a space. Let me erase some of this pre-work there. Okay. And by putting those spaces, it reminds me that I'm trying to add something there to make this x squared plus 6x a perfect squared trinomial. Okay, so I've regrouped the quadratic and linear term together, leaving the constant on the outside. I'm going to check now to make sure in front of the x squared I just have a 1, and I do. It's just x squared there. And so at that point I can run off to the side and I take my b value of 6, I divide it by 2, and I square it. Okay, that's 3 squared, so it's 9. So I'm going to add a 9 inside those parentheses. Now I've added 9 to the right hand side of my overall equation, so out here I subtract 9. 9 and negative 9 add up to 0, so I haven't changed the right side of my equation in terms of how much it's worth, its value, but I have made it so that this quadratic now factors, and it's going to be a perfect square each time. In other words, the two binomials will be identical. And that's what we call completing the square. I've now rewritten it as x plus 3 times x plus 3, which is x plus 3 squared. And outside I just let the math do the math. I've got negative 14. And now I'm in vertex form. It matches up with y equals a x minus h squared plus k. Okay, and we can list those values. A in this problem now is 1. There's a 1 out there I can't see. Notice the difference in sign here. Sign in the h area inside that perfect square. What that tells me is that h is negative 3. And out here I've got a difference in sign, so k must be a negative 14. And so my vertex is at hk, negative 3, negative 14. Axis of symmetry, x equals negative 3. And that problem's done. The next one here is problem number 199. You notice there's a little difference in this one than the previous. In this case I have an a value. I start the problem essentially the same way when I go to vertex form. I group my x squared term and my linear term together. Okay, I can leave a little space here if I want to indicate that I'm going to have to be adding something. But I'm not ready to add yet, again because of this 3. I have to have just a 1 there. And so the way we remedy that is I factor a 3 out of this quadratic and this linear term. Notice I'm leaving my spaces there still. Because now I'm ready to complete the square on the stuff inside of the quadratic. So I'm going to take my b value and divide it by 2. And I'm going to square that. Now 3 is not divisible by 2, so I'm going to leave it as a fraction and square the top and the bottom. I'm going to add 9/4. This is where the math gets really tricky. It looks like I added 9/4 to this right side of this equation, but really because of this 3 out here, I've added 3 times 9/4. Well, 3 times 9/4, let's do the math right here, is 27/4. 27. There we go, 27/4. So 3 times 9/4 gives me 27/4. That's what I've added to the equation, so now I have to subtract 27/4. So I've essentially added nothing to this problem. Now I've got a perfect square. I leave my 3, but this quadratic is now factorable. X and 3 over 2. 3 over 2, they both have to be positive. There's my perfect square. Okay, that's what I wanted. I still have to do a little math out here. I want to add a -2 and a -27/4. To do that, I'm going to get a common denominator of 4. 8 over 4 is still equal to 2. And now I can add these with the common denominator. I get -25/4. So there is my equation in vertex form. My vertex would be located at, again, I look inside here. Let's grab the red marker. There we go. -3/2 makes that 0 inside. And outside it is -25/4. So there's my vertex. And that is pretty much all there is to it. You do have to really watch out for having an a value other than 1, because you got to multiply it by what you add in order to figure out what to subtract. And that's it. Hope the homework goes well for you. I believe I assigned 185 through 201, just the odd problems, to give you practice with this. Do as many as you need to get it down and get it memorized and mastered.